Well, hello there and welcome YouTube. This is Mr. Robinson with yet another math review video. This is on polynomial equations and factoring, a great overview with 55 example problems. That's right, kids, that's what we're dealing with today. Now, here are the bullet points. Here's the laydown. These kind of 8 topics, these 8 sections. Quite a few problems to go here. You know, I'm going to do more so the process and much less the instruction when it comes to it. So I'll say how to do the problem. I won't say as much why, just so that way I can make this a lot shorter than it needs to be. Sometimes I'll do different ways of doing problems, like say when it comes to multiplying polynomials or factoring, I'll show different methods, but I'll probably show one method per problem. Here we go. Okay. We are going to, for adding and subtracting polynomials, which is not really what we're going to do here as far as combining like terms, but they are terms here that are added and subtracted. Let's see what we're going to do. Write the polynomial in standard form. Identify the degree and leading coefficient of the polynomial. Then classify the polynomial by the number of terms. Now, first of all, write the polynomial in standard form. What we're going to do for all these problems here is make sure that the highest degree goes first. So for number 1, or this first problem right here, 6 plus 2x squared, this has degree of 0, this has degree of 2. I'm going to rewrite this as 2x squared plus 6. Okay, the second part, identify the degree and leading coefficient of the polynomial. And a polynomial's degree is based on its leading degree. So this has a degree of 2. And its leading coefficient is the coefficient of the leading term, which is also a 2 in this case here. And finally, classify the polynomial by the number of terms. And of course, I also want to do and degree as well. I just love to do both of them because there's a name for degree here. When we do this, this is a quadratic for being degree 2. It's a quadratic, but based on number of terms, which is also 2, it's a binomial. So quadratic, binomial. Everything here is a 2. That's a 2, 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 that's a 2. Perfect. All right. Second question here. We have negative 3p cubed plus 5p to the 6th minus 4. This has degree of 3. This has degree of 6. This has degree of 0. So I'm going to go ahead and write that 5p 6th first. And then I'm going to write minus 3p cubed, not because there's a minus right here, but because there's a minus in front of the 3p cubed. And then the minus 4 there. That is the polynomial written in standard form. The degree of this polynomial is 6. Again, it is based on the leading term here. And the leading coefficient, of course, also based on the leading term, is a 5. That is the leading coefficient. And last but not least, this is a 6th degree. I'm not going to say anything else other than 6th degree. I won't say it's, I believe it's called a sextic degree. And it's a trinomial. Great. Now, you haven't learned much about why we're talking about leading coefficient. It's more about whether it's positive or negative. It's one of the biggest things to talk about for these things here. Okay, the third problem right here, 9x to the 7th minus 6x squared plus 13x to the 5th. It's almost in order. This guy is at least right because this is of degree 7. But this guy's of degree 5, whereas this guy's of degree 2. So 13x to the 5th goes next, and then minus 6x squared. Next part here, the degree, as I said, is 7. Again, it's based on the leading term. That's not going to stop. And the leading coefficient is 9. And finally, it is a 7th degree polynomial. I actually don't know what that's called in any sort of way. It's a 7th degree, and it's a trinomial because it's 3 terms. Of course, the trinomial is the more important part about this. They asked us to classify by the number of terms, but let's do both the degree and the number of terms. I think that's just as appropriate. And the last problem here, obviously, it looks like there needs to be reordering as well. This is of degree 1. Just so you know, and that's of degree 3. So the 8y cubed should be written first, and then minus 12y. It is of degree 3, as again, it's a cubic there, and its leading coefficient is an 8. And then it is a cubic, third degree is a cubic, and 2 terms is a binomial. A 1 degree would be called a monomial. A 1-term polynomial would be called a monomial. A 4-term polynomial would be called a quadrinomial. After that, you could say 5-term polynomial, stuff like that. Okay, find the sum or difference. Now, for these kinds of problems right here, we're literally going to be adding or subtracting whatever's there. With these parentheses here, they're not really doing anything to this. I might as well just rewrite this as 3a plus 7 plus a minus 1, don't fall into the trap of thinking you're supposed to distribute because there's a plus. So I'm going to reorder these here. I'm going to write the 3a and the a right next to each other. These terms should combine. And then that 7 and that negative 1 right next to each other there. 3a plus a is 4a, and 7 minus 1 is 6, so you're left with 4a plus 6. That's what happens when you combine. You know how you can double check any of these is by plugging in a number for a. Try not do 0, 1, or 2 for many reasons, but plug in 3, and you'll see that this will match the same thing as what this was. I'm not going to do that, though. I'm going to be time sensitive here. Next problem, once again, is this is a plus, and nothing's outside these parentheses here. The parentheses aren't really doing anything. So if anything else, they're probably there to confuse you. I assume they're there because, as you can tell, all these are written in standard form when they have these in parentheses. And then what it looks like they're doing is keeping that in standard form and just calling them two different polynomials when you do. Okay, what am I doing now? I'm reordering these again. There's the x squared and the 2x squared, then the 6x, and then the negative 5 and the 15 in standard form. You know what also would be nice for you to do? Cross these out as you go. Hey, there's the 2x squared. I took care of that. There's the 6x. There's the negative 5. There's the 15. So now you know exactly that you took care of all that you needed to. That's a 3x squared. That's a 6x. And that's a 10. Negative 5 plus 15 is 10. And that is your answer. Whoa. All right, third problem here. P plus 7 minus 6p squared minus 13p. Okay, this minus does affect things. It subtracts both the 6p squared and subtracts the 13p. Kind of like distributing a negative 1 into both of them. So this is minus 6p squared minus positive 13p. So it's not that it turns them negative, but it does change their sign. So minus 6p squared minus 13p. Best to write this thing in standard form, of course. It's always a great practice. So I'm going to put this at first, negative 6p squared. Then I'll put the plus p, the minus 13p, and then the plus 7. And these two here should combine. That's a 1 minus 13. That's a negative 12. So negative 6p squared minus 12p plus 7. And there you are. I gave myself just enough room there. Just enough. All good. All good there. Okay, this quantity, negative y squared plus y plus 2, and we are going to subtract y squared minus 5, y minus 2. And again, these around parentheses aren't meaning very much here. Just going to write that without parentheses right there. But this one here around parentheses is important, again, because it's being subtracted. So I'm going to subtract all of these quantities here. And again, this is a step. You know, there's another minus in this problem. I'm not going to do this step next time, but I will show you what's happening each time. I'm subtracting the y squared, I'm subtracting the negative 5y, and I'm subtracting the negative 2. So what happens when you subtract a negative? Well, it becomes addition. So it's a minus y squared plus 5y plus 2. Now rewrite things next to each other. Here's that negative y squared with this negative y squared. Believe me, those do not cancel out. You don't want to make that mistake. Plus y plus 5y plus 2 plus 2. Okay, now when those combine, negative y squared minus y squared is negative 2y squared. Plus y plus 5y is plus 6y. Plus 2 is plus 4. And there you are. Nicely done. Thank you. Oh, my pleasure. Okay, 2x cubed plus 6x squared minus x. Again, nothing's affecting the thing around parentheses there. This time I'm going to write this without that extra step. Minus negative 3x cubed, that is plus 3x cubed. Minus negative 2x squared, that is plus 2x squared. Minus negative 9x, that is plus 9x. So all these negatives became positive because you were subtracting the negatives. 2x cubed plus 3x cubed plus 6x squared plus 2x squared minus x plus 9x. Okay, good read right there. We got a 5x cubed plus 8x squared. Negative 1 plus 9 is 8 plus 8x. And there you go. That is your adding and subtracting for you. Now, there might be more adding and subtracting in the future problems, but this one's specifically for adding and subtracting. Okay, multiplying polynomials. Let's go ahead and find the product. A lot of different ways you can do this. One general way, which I probably won't do ever again next time, is I can multiply this entire quantity with both of these things here. The x plus 7 can multiply with x. That's proper distribution. and the x plus 7 can multiply with the negative 9 here. Then I distribute the x into the x and the 7, and I'll get x squared plus 7x. Then I'll get negative 9 distributing into these two, minus 9x minus 63. In this case, I'm going to get these two like terms combined, x squared minus 2x minus 63. There we go. Next problem here, this time I'll do classic distribution. Multiply each term in one polynomial, one quantity with every term in the other quantity. The x will multiply with x in negative 4. The 6 will multiply with x in negative 4. You'll be left with x times x plus x times negative 4 plus 6 times x plus 6 times negative 4. Okay? So, x times x is x squared, x times negative 4 is negative 4x, 6 times x is 6x, and 6 times negative 4 is negative 24. Combined like terms, you'll get x squared plus 2x minus 24. And that's all she wrote. That's all, folks. All right. Y minus 5 times 3y plus 8. I'm going to do the same thing here, only this time I'm going to treat it more as FOIL. And guess what? The same thing happens. But let's talk about first, outside, inside, last. What I do first is I multiply the two first terms, y times 3y. What I do next is I multiply the y with the 8. Then the inside terms, the negative 5 and the 3y, multiply together. Now remember, this is no different from what I just last did. Just you say it differently, a different perception might come in place there. So I'm doing the exact same thing here. So I'm going to get 3y squared. This will be plus 8y minus 15y minus 40, which is 3y squared. 8 minus 15 is negative 7 minus 7y minus 40. And there you go. By the way, make sure these are all left in standard form. Not that it's too hard here regardless. Okay, here I'm going to go ahead and distribute again. You know, I'll show x times x squared. You know, things might not necessarily combine here because now that's the x squared. So x times x squared is x cubed. I have x times 7x, which is 7x squared. Oh, it looks like things will still combine here. 4 times x squared is 4x squared. And 4 times 7x is 28x. So that becomes x cubed plus 11x squared plus 28x. There you are. You know, all I'm doing is simplifying, doing them kind of as fast as I really can here. For the last problem here, though, what I'm going to do with the trinomial, I'm going to draw out this box for you to show this one last method, especially when it gets this large. Maybe you prefer this more. You don't get lost in your own work. You make sure that you don't accidentally FOIL. You get everything kind of working out right. What I have is a binomial multiplied by a trinomial. So I have negative 3y plus 1 multiplying with 4y squared minus y minus 7. So negative 3 times 4 is negative 12. Y times y squared is y cubed. 4y squared times 1 is 4y squared. Negative 3y times negative 1 is a positive 3. Y times y is y squared. So that's 3y squared. Negative 3y times negative 7 is positive 21y. Negative 3y times negative y, negative y times 1 is negative y, and negative 7 times 1 is negative 7. So when I'm done here, I'm going to write the one last step here. When I'm done, all I'm going to do is combine any like terms. Looks like, I wrote a cubed here. I think I said squared, but I wrote it cubed. That should be squared. What I'm going to do is I'm going to combine the squareds, the quadratics, and I'm going to combine the linear terms right here. So let's see what we get out in the end. There's the negative 12y cubed for starters. Then I have 4y squared plus 3y squared is 7y squared. 21y minus y is 20y. And then there's the negative 7. And you're left with that there. So that might be a little easier for you to do than write out the 6 different terms in kind of that other way, if you know what I mean. I think that might help out for you in that case. Okay, special products of polynomials. Now, this is no different from the other stuff, so I'm going to start it like the other stuff there, but you got to know what you're doing, and if there's a pattern you want to figure out, you got to pick that up. So I'm going to start with FOILing, not writing anything else. This is x times x, which is x squared. I have x times negative 9, that's negative 9x. 9 times x is 9x. 9 times negative 9 is negative 81. Well, good news is these two cancel out, and you're left with x squared minus 81. Now, this x squared minus 81 also happens to be x squared minus 9 squared, and this is true for all difference of two squares here. So this pattern remains for every a plus b times a minus b thing that we have occurring here. So here's one, and by the way, down here is one. So let's take a look at this as a difference of two squares here. If we're going to multiply this like a plus b, a minus b, because a squared minus b squared, this becomes 2y squared minus 4 squared. 2y quantity squared is 4y squared. 4 squared is 16, and we're going to subtract the 16, and that's all you get for that answer. I'm not going to say anything beyond that. That's it. All right, p plus 4 quantity squared, by the way, is not p squared plus 4 squared, so don't distribute that too. No, instead do p plus 4 times p plus 4, and then FOIL that baby out. P times p is p squared. This is going to be plus 4p plus 4p, so that's plus 8p. And then 4 times 4 is 16. So we're going to get p squared plus 8p plus 16. And one great thing with these ones here is this was the first term squared. This is double the two terms inside there. And then this is the last guy squared. I'll make sure to follow that pattern next time. Otherwise, you can always FOIL. Negative 1 plus 2d quantity squared. If I follow this pattern here, what I'm going to do is I'm going to square the negative 1. I'm going to double the product of the negative 1 and the 2d. And then I'm going to square the 2d. This is what comes out as a result. It's not to say whether this one's easier or harder to do than the other way. This might take just as long. Depends on how long you take doing it. So this would be the final answer here, but I'm going to go ahead and also write this one in standard form, 4d squared minus 4d plus 1. Try and write everything in standard form that you can. That'd be fantastic for everybody involved. Okay, 6x plus 4y quantity squared. See if we can do it without writing this step. We're going to square the first term. 6x quantity squared is 36x squared. We're going to double the product of these two guys. 6 times 4 is 24, times 2 is 48. So 48, and then these x's and y, the y multiply, 48xy. Plus 4y quantity squared is plus 16y squared. And that's it. Of course, I'm always trying to find ways to speed things up. Here it is. Here's one of those methods. And last but not least, or maybe it's least, I don't know, we have another difference of two squares. We have an a plus b times a minus b. Let's see if we can do this without writing the step out. We're going to square the 2x, that's 4x squared, minus, we're going to square the 3y, that's 9y squared. And that's it. Again, the middle terms cancel. The middle terms cancel in a difference of two squares. Okay, solving polynomial equations in factored form. Now this is the big part right here. Once it's set equal to 0 here, we can solve using what's called zero product property. If a times b equals 0, either a equals 0 or b equals 0. So if x times 6 times x minus 8 equals 0, either x plus 6 equals 0 or x minus 8 equals 0. As long as this is in factored form as a product and set equal to 0, this is very easily solvable. Subtract 6, we get x equals negative 6. Add 8, we get x equals 8. And those are your two answers. Either one or the other can work. X squared plus 5x equals 0. This is not yet a product. If we turn it into a product by factoring, find the greatest common factor here, that's x. And what's left is x plus 5 equals 0. You have one of two possibilities, either x equals 0 or x plus 5 equals 0. If x plus 5 equals 0, subtract 5, you're going to get x equals negative 5. And what's great about these problems here, of course, is once you're stuck in this, or once you're at this step right here, you can see that you just got to put in the opposite number that goes here. That's not always true. If there was a 2 right here, obviously it wouldn't be negative 5. It would be negative 5 halves. You'd have to do more algebra. But once you learn more mental math, you can kind of figure that out along the way. All right, this is once again factored form. Don't distribute this, please. Make sure you multiply that thing out and turn it into the product, or I mean, keep it multiplied as a product that it should be. Either z plus 3 equals 0, in which case z would equal negative 3. I wrote an x. Almost wrote an x again. Z equals negative 3. Or if z minus 7 equals 0, z would equal 7. Okay, there's one or the other. That's it, right? b plus 13 quantity squared equals 0. So that does mean b plus 13 times b plus 13, if that does help you. That equals 0. So either b plus 13 equals 0 or b plus 13 equals 0. Hey, there's no other way to write it. B's got to equal negative 13. Whether you write it twice or just once, this is said to have a multiplicity of 2. But that's the only answer that satisfies this thing here. And finally, 2y times y minus 9 times y plus 4 equals 0. Again, this is a product. This is multiplying with these two things. So either 2y equals 0, in which case divide by 2, y equals 0. Again, that's where you can plug in 0 to make this whole thing equal 0. That's awesome. Or y minus 9 equals 0, so y equals 9. Or y plus 4 equals 0, so y equals negative 4. And again, only do that, it's just the opposite, man, if you know exactly what you're doing or can mentally solve that. Again, I divided by 2 going from one to the next right there. Now, this is an or and an or and an or. If I didn't write it before, it's okay. Just don't write and. Okay, factoring x squared plus bx plus c. And compared to the other one, this is where x is going to equal 1. And there's a great thing about it. Let's take a look at this. The question that is asked is what two numbers multiply to become negative 27 and add to become 6. So I can list factors of 27 here, which are 27 times 1, 9 times 3. Is that it? I think that's it. Now, 27 is negative, so that means one number is positive, one number is negative. This is a positive sum, which means the negative number should be smaller. So 27 minus 1 is 26. 9 minus 3 is 6. It looks like it's the 9 and the negative 3. Now, if we solve using a method called factoring by grouping, what you can do is turn the 6 into both terms here, 6x into 9x minus 3x. And what you can do is find the greatest common factor of your groups of terms here. The greatest common factor of x squared plus 9x is x, and the greatest common factor here is a negative 3, and you're left with x plus 9 inside there. And as x plus 9 is a common factor of both terms, if I factor out the x plus 9, I'm left with x minus 3. Now, I'm not going to do factoring by grouping for the rest of these problems because one bit of recognition here becomes that this 9 and this 9 is the same thing as this negative 3 and this negative 3 are the same thing. The numbers that you find here end up being in the answer as well. That's why I'm not going to do the factoring by grouping on these problems anymore. So I'll just do it more mentally. P squared plus 2p minus 35. We're asking what two numbers multiply to become negative 35 and add to become 2. You try 35 and 1 and 7 and 5. Negative product positive sum means the smaller number is negative, and it looks like 7 minus 5 equals 2. You can see where I start to speed this up more and more as we go. So that's 7 and negative 5, and those two numbers end up also being in the result. That's p plus 7 times p minus 5, and that's your answer. How do you double check? You can distribute this back out and make sure that everything goes all right. Let me turn this into a nice different color here. Angry red. There we go. All right, let's go with happy blue now. B squared plus 18b plus 80. What two numbers multiply to become 80 and add to become 18? You can try some numbers. Start with 80 and 1. You'll realize it's too large. Try an obvious one. 20 times 4. No. 10 times 8. Oh, yeah. 10 plus 8 is 18. 10 times 8 is 80. So that's a 10 and an 8. And the reason why that was probably even a little easier is because both of these were positive. So I know I'm just going to try positive numbers. And 80 has a lot of factors, but you try some obvious ones first and you see if you luck out. And I did. See, I didn't try the 16 times 5 or anything like that. Okay, z squared minus 4z minus 21. I'm asking what two numbers multiply to become negative 21 and add to become negative 4. Let's see if we can do this one mentally without writing anything else besides, obviously, the z and the z, because, of course, that's what it'll come out to. Well, negative product, negative sum. That means one number's negative, one number's positive. The larger number will be negative. So you try negative 21 and 1. No, negative 21 plus 1 is negative 20. Try negative 7 plus 3. Negative 7 plus 3 is negative 4. Okay, that's it. Negative 7 and 3. Told you I'd be fast if I could. And I mean, look, to be honest, I can do this a lot faster, but I don't want to just write the answer. What two numbers multiply to 28 and add to negative 11? Well, two negative numbers, apparently. So try factors of 28. like 28 and 1, that adds to negative 29. 14 and 2, that adds to negative 16. 7 and 4, that adds to negative 11. So it's a negative 7 and negative 4. See how fast those can become when you do them mentally. That's great. Okay, factoring. Ax squared plus bx plus c. These ones are a little bit different here. First things first, and it's true for these as well, but look for a greatest common factor. These won't have one specifically because only these two have x, and this will have a 1. But if these have a greatest common factor of some sort of number, we can try and divide it out if possible. There is no greatest common factor here, as I can only divide this by 5 or 1. These can't divide by 5. So it looks like I have to keep these as is. Now, when I do this one, I'm going to have to ask what two numbers multiply to something and add to something. Now, I'm not going to teach this in full at all. I'm just going to do the problem. I'm going to say what two numbers multiply to 5 times 7, that's 35, and adds to 36. Clearly, that's 35 and 1. 35 plus 1 is 36. 35 times 1 is 35. So now we factor by grouping. We're going to say 5x squared plus 35x plus 1x plus 7. And you're going to find a greatest common factor of these two terms and these two terms. Greatest common factor here is a 5x. I factor that out. I'm left with x plus 7. Now here, I know it just says plus x plus 7 and there's no greatest common factor, but that means just write out the factored 1. You'll thank me later because that way you know that that 1 exists as something. And x plus 7 is a common factor here and here. So if we factor out that x plus 7, you're left with 5x plus 1 over here. Double check and you should be solid. 3t plus 16t, 3t squared plus 16t minus 12 almost has the greatest common factor of 3. It appears that this one does not. That's a shame. So, in fact, it doesn't look like any of these have a greatest common factor, which is a shame, but hey, you still deal with it as need be. So, 3 times negative 12 is a negative 36. What two numbers multiply to become negative 36 and add to become 16? Let's try some numbers here. By the way, positive sum, negative product. So 1 positive, 1 negative. 36 and 1, no. 18 and 2, yes. So 18 and negative 2. So if I rewrite this out, here by expanding this thing to 3t squared plus 18t minus 2t minus 12, I can factor by grouping. Factor out the 3t from these two terms here, and you're left with t plus 6. Factor out the negative 2 here, and you're left with t plus 6. See, if I factor out a positive 2, I won't have t plus 6 there. I'll have negative t minus 6. So you factor out the t plus 6 from both terms, and you're left with 3t minus 2 in the other guy right there. That's all she wrote. Now, these can be done faster here. There's one common factor here that I'm going to pull out for this next problem. Negative 5y squared minus 22y minus 8, and that's a negative 1. If I factor a negative 1 out, or just the negative, I'll have 5y squared plus 22y plus 8. Trust me, it's a lot easier to see it that way, at least for myself here. I'm going to go ahead and do this one mentally. Okay, I'm going to do this one mentally. Mental. And in doing so, the idea is if this is factorable, that means that I know it's going to come out like this and that. As this is a y times y deal here, the only way to make this 5y squared is if one of these is a 5y. Because 5 is a prime number, there's only one number I got to try there. Now, all these are positive, which means this will definitely be a plus and plus. There are only two ways to multiply to 8, either 8 times 1 or 4 times 2. Well, so you can either try 8 times 1 here, or 1 times 8, of course. 5y times 1 is 5y, plus 8y is 13y, that's out. 5y plus 8 is 40y, that's out, clearly. So try 4 and 2. By the way, I know what the answer is already, I'm delaying you a little bit. 5y times 2 is 10y, plus 4y is 14y, nope. 5y times 4 is 20y, plus 2y is indeed correct, that's 22y. So 2 and 4 go in there. Now, if you do this enough and you know your math enough, you'll probably be able to see the answer before you actually try them and write them out like that. Let's see if I can do it with this one. 6x squared plus 17x plus 7. Okay, once again, no greatest common factor, but these are positives, so I know that some good's going to come out from this. Either my answer is going to appear as 6x times 1x or 3x times 2x. And I'm going to try my factors of 7 here, 7 times 1, and try and write them in the right spots to get this thing to work. So let's try, here we go, 7 and 1. 6 times 1, boom, 6, plus 1 times 7 is 13. Nope, that's not it. 6 times 7 is 42. Nope, that's not going to be it. Neither of these. Let's try 3x times 2x. 7. 3 times 7 is 21. Plus, no, that's not going to be it. 3 times, let's see, this would have to be it. 3 times 1 is 3. 2 times 7 is 14. 3 plus 14 is 17. So it looks like that one's it there. There's my 17x that I get from foiling. And again, if you want to know how to do this more, there is a video that I have on this. I'm preaching it right now, but I'm doing it a little bit there. Once again, with this one, I'm going to factor out a -1 here. It's just going to be a lot easier looking at that thing as a positive, at least in my mind. And in fact, I would prefer you factor that out to begin with anyway. So you factor out the -1, and you're left with 2y squared minus 7y plus 6. Okay, I'm going to go ahead and do mental factoring again. I just love it so much. I'm going to keep reinforcing it as often as you can see it here. This is going to be some sort of 2y times y. That's what gets you 2y squared. And 3 times 2 is 6, or 6 times 1 is 6. Notice how the sum is negative here, so this is going to be a minus and minus with a positive product. So right here, I'm going to go ahead and try 6 and 1. That's negative 12. No. 6 and 1, that's a -2 minus 6. That's close. It's -8, but that's not going to be it. So let's try 3 and 2. 3 and 2. So 2 times 3 is 6, minus 10, no. So let's try 2 and 3. -4 minus 3 is 7. So there it is. Okay, you're probably sick of me doing mental factoring, so I'm going to go ahead and do another way here. Kind of like the factoring by grouping, only this time use rectangles. We're going to find out what two numbers multiply to become -27 and add to become 26. Well, that'll be 27 and a -1. 27 minus 1. Boom. So what I'm going to do is draw a rectangle, and inside that rectangle, instead of writing items on the outside, I'm going to write the items on the inside, and I'm going to figure out the numbers on the outside. So this will be a 3z squared. On the other side will be the -9. Inside these two will be the 27z and the -1z, the minus z. So now what I'm going to do is find out what exists on the outside of these. Clearly this will have to have a z and a z. And where will the 3 go? The way where the 3 can multiply with one of these other two numbers. 3 can multiply with something to give me 27, a 9. Z can multiply with a -1 to give me a -z. And just for good measure, -1 times 9 is indeed -9. So this factors out to 3z minus 1 times z plus 9. There you go. And the last problem, I'll do factoring by grouping one last time here. 10 times -3 is -30. What two numbers multiply to become -30 and add to become -13? You might think 10 and 3 work, but remember it's a -30. It's a -30. So -10 times plus -3 is -13, but -10 times -30 is +30. Looks like it's going to be a -15 and a +2, right? 10 times that is -30. So -15 times -15 times 2 is -30. -15 plus 2 is -13. So we'll have 10a squared minus 15a plus 2a minus 3. Greatest common factor here is a 5a. I'll be left with 2a minus 3. And greatest common factor here is just a 1. And I'll be left with 2a minus 3. Factor out the 2a minus 3 from both terms here, and you are left with, in the other set, 5a plus 1. And there is your factored answer. By the way, if you can't find two numbers that multiply to this and add to this, it's going to be not factorable. In this case, these were factorable. Notice how I factored the negative outside the leading quadratic coefficient if I could have. Okay, 7-7, factoring special products. Okay, we have x squared minus 16. Now, if you don't know what to do in terms of factoring this one, always rewrite it as a quadratic trinomial. That may help you. So I can rewrite this instead as x squared plus 0x minus 16. And I asked the same question as I always have asked before. What two numbers multiply to become -16 and add to become 0? So what two numbers multiply to become -16 and add to become 0? That's a 4 and a -4. Heads up, they'll always be additive inverses. That's what gives you 0. or they could both be 0, but 0 times 0 sure isn't negative 16. So that's x plus 4 times x minus 4. And this should ring familiar. This is the a plus b, a minus b that gives you the a squared minus b squared. So this is a difference of 2 squares. This too is a difference of 2 squares. Now how did this show up here? That is because this is x squared minus 4 squared. Of course, we've seen that a couple times now to get to this. So this guy, as this is also a difference of 2 squares, this is x squared minus 3 squared. That's not factored form, but this is your a squared minus b squared, which becomes a plus b times a minus b. You don't even have to ask the question what two numbers multiply to this and add to that. As long as they're perfect squares, you will find your two numbers. Hopefully you recognize how those are perfect squares and how that works out to give you that square value as a negative and how they cancel each other out there. Y squared minus 100. Once again, this is y squared minus 10 squared. So this will be y plus 10 times y minus 10. You can see the rate at which I'm going to try and speed these things up for you. All right, the bottom ones are a little different. These are no longer difference of 2 squares. What you do have, though, is something a little special. Let's see, what two numbers multiply to become 9 and add to become negative 6? Well, it's negative 3 and negative 3. So that becomes z minus 3 times z minus 3, which could be your answer, and it is. It's not wrong. It's better written as z minus 3 quantity squared. You see, this is a perfect squared trinomial. This guy and this guy are interchangeable. This expands out to that. And what did we say before? That this is the z squared. Let me try and rewrite that. This is the z squared. This is double the product of the negative 3 and the z. And this is the negative 3 squared. Okay, so next problem, m squared plus 16m plus 64. Again, you start to recognize, hey, that's clearly a quadratic just because it's a quadratic. So it's something squared, and this is also 8 squared. Well, what would be great is if this is double the product of the 8 and the m. And you know what? It is. 2 times 8 is 16. So this lands to be a perfect square trinomial. And just like you saw here, we did z minus 3 quantity squared. Well, this is going to be m plus 8 quantity squared. So as long as there's recognition that that's what's happening there, you can go ahead and do that. You got to recognize the perfect squares involved, though, in the front and back. So in this last problem here, I do recognize once again that there is a perfect square up here. That's 5x squared. That's 5x that's being squared. And this is a 3 that's being squared. Now, one of these will have to be negative because this is negative here. So if this is 5x, I'm trying to do it without writing anything. If this is 5x squared, and say this was negative 3 squared, is this double the product of 5 and negative 3? 5 times negative 3 is negative 15. Double is negative 30. Yes, it is. So this will become 5x minus 3 squared. And again, if you know what you're doing there, you can do it. If you don't, hey, multiply 25 times 9, ask what two numbers multiply by that and all that, and you can keep going. But if you recognize this stuff, it'll go a long way. 7-8, factoring polynomials completely. Okay, how's this different from the other stuff? Well, just might be harder, more complex things. You can see some cubics and some quartics. Here's a quadratic with some weird stuff going on. What's going on here? Well, we wouldn't give you these problems if they weren't factorable in a nice way, such as factoring by grouping. This x cubed plus 4x squared, I can factor an x squared out. I'll be left with x plus 4. I want to factor out a negative 3 from these two guys to be left with x plus 4 here as well. And now when I factor this x plus 4 out, I'll be left with x squared minus 3 over here. Now, if the x squared minus 3 could have factored more, I would have. That's the completely portion of this. All of these got to be factored completely. Leave no stones left unturned. 2x to the 4th minus 8x squared. This has a common factor of 2 and x squared. And then here you're going to be left with an x squared. 2x squared times x squared is 2x to the 4th. And here you'll be left with, it looks like a negative 4. So you might say you're done, but this can factor more. X squared minus 4 is a difference of 2 squares. That is x plus 2 times x minus 2. And now you're done. Now you've solved everything that you're supposed to for that. Well, you haven't solved anything, but you factored completely. That was the gist of it. Find common factors and go. Same with this one here. As it's a cubic, it might be hard to factor from the onset, and I'd agree. However, there's a common factor of x, and in fact, there's a common factor of 2 as well. If you factor 2x out, you're left with an x squared here, a 9x here, and a minus 36. Minus 36 right here. And hopefully this thing inside's factorable. If not, we're going to leave it like this. What two numbers multiply to negative 36 and add to 9? Well, it looks like a 12 and a negative 3. 12 and negative 3. So x plus 12 times x minus 3. And again, because this was a 1x squared inside here, I know that the answer to that question that I just asked is also these numbers here. And that's completely factored. N cubed minus 6n. I can factor an n out. Let me use a different color. I can factor an n out, and I'll be left with n squared minus 6. Now, this doesn't factor out anymore. I mean, look, if you want to write out n plus root 6 and n minus root 6, and you know what you're doing with that, then by all means be my guest. But I'm going to accept this as the answer right here. That'll be fine. You probably don't know what's going on there as much. Just this one's acceptable. If this was a perfect square, though, now we got to look at doing an actual difference of two squares. Okay, this problem's kind of weird, and as you're looking at it, you're like, what the heck's going on? Well, keep in mind that we are talking about factoring by grouping here, and if you recognize this a being involved in only the last two terms, it's likely that's one of your common factors. So try factoring by grouping. Even if it's wrong, you can still try it. I factor an x out, I get x minus 3. Just so you know, I haven't tried these problems yet before, so I'm doing this with you for the first time. But I factor a 4a out. Notice how both these have a multiple of 4 and a multiple of a. And here I'm left with an x. Here I'm left with a minus 3. That's good, because both these quantities are x minus 3. Factor out the x minus 3. Here you'll be left with x plus 4a. And if anything else could factor, I would do it, baby. But hey, nothing else is factorable. I'm left with that. I'm good and great. And the final one here, 2x to the fourth plus 2x cubed minus 20x squared. It's clear that 2 is a common factor. It's pretty clear that x squared is a common factor. So here you're left with an x squared plus, it looks like x, 2x squared times x is x cubed, minus 10. What two numbers multiply to negative 10 and add to 1? Well, as you take a look at this, I don't know if anything's there. You can try 5 and negative 2, that equals 3, and 10 minus 1 equals 9. So it looks like nothing it looks like nothing's the answer to that question there. That doesn't mean this thing's not factorable. It means this is not factorable, but we factored out the problem as much as we could. We don't write not factorable here. We factored it out as much as we could, and that's all that we could. And that's it. Okay, solve the equation. So what's left on these problems here, just like the other solve the equations, is get them in factored form, and then you'll be set to use zero product property. So let's factor out. It looks like we can factor out a 3 and an x. That's great news. That way we don't have such big things to deal with, such as in this quadratic, now it's a 1x squared. We have a minus 3x here, and here we have a minus 18. Now, I have more I can factor here, at least I assume. It looks like I do. The two numbers that multiply to negative 18 and add to negative 3 are a negative 6 and a positive 3. And again, mental factoring brings you so far so fast. So either 3x equals 0, in which case if you divide by 3, you get x equals 0. Or x minus 6 equals 0, in which case when you add 6 over, you get x equals 6. Or x plus 3 equals 0, in which case when you subtract 3 over, you get x equals negative 3. Those are your three answers. I can fit it in my little box right there by doing some mental work. 6x squared minus 36x equals 0. This looks like it may be a difference of two squares kind of problem. In fact, it is. Before doing the common factor, well, yeah, here, let's go and do the common factor first. I can factor a 4 out, I think at most. Let's see, double check that. And I have 4x squared minus 9, and that equals 0. So this is a difference of two squares as well as this was here, but this would help me factor more completely. That's why I wanted to do it this way. This is a 2x quantity squared. This is a 3 quantity squared. So this is 2x plus 3 times 2x minus 3. And that equals 0. So zero product property here, either 4 equals 0, which is impossible to do. Looks like that's nothing. That doesn't mean anything to us. Or 2x plus 3 equals 0. Or 2x minus 3 equals 0. Here you subtract 3 and divide by 2. You get x equals -3/2. Here you add 3 and then you divide by 2. You get x equals +3/2. There you go. The last one here is it's a cubic quadrinomial. It looks like there's some good factoring by grouping involved here. That's great. So I factor out a z squared here. I'm left with z plus 3. And I can factor out a -25. That's a lot. And you're left with z plus 3 right here, all set equal to 0. So factor the z plus 3 out of both terms here, and you have z squared minus 25 over here equals 0. This is a difference of two squareds. That's z plus 5 times z minus 5. And that's z plus 3 equals 0. So either z plus 5 equals 0, so z equals -5, or z minus 5 equals 0, so z equals 5, or z plus 3 equals 0, so z equals -3. Yay! Okay, well, not the last problem. I have two more word problems after this. A box in the shape of a rectangular prism has a volume of 96 cubic feet. The box has a length of x plus 8 feet, a width of x feet, and a height of x minus 2 feet. Find the dimensions of the box. So what they're talking about is something in 3D here. It's a rectangular prism. What that means is a rectangular base, and then they go straight up like that. So, think like a shoebox. Okay, it has a length of x plus 8 feet. I'll go and write this as x plus 8. It has a width of x feet and a height of x minus 2 feet. When you multiply these all out, which is what they're saying, length times width times height, you're going to get 96. So x times x plus 8, and notice the strategy here. I put the x first. It's just easier for me to work with, equals 96. Now, this is not set equal to 0, so you can't use zero product property. You can't say either x equals 96 or x plus 8 or x minus 2. No, this was kind of tricky. We have to set this equal to 0 by subtracting that 96 over. The problem now, of course, is that this is no longer just a product. Here's a product and here's a difference. We cannot still say that either x equals 0 or whatever. We have to involve this in it. So here's what you got to do. First, start by distributing this stuff out. Then combine like terms. Then factor back down. And then see what you get as a result of that. Kind of tricky. But I'm going to go ahead and distribute these. And then I'm going to multiply the x in there afterward. So this is all x times x squared minus 2x plus 8x minus 16 minus 96 equals 0. So this will be x cubed plus 6x squared minus 16x minus 96 equals 0. Okay, now I have to factor down. Now that they're all clustered together, and rightfully so, I can do things like factoring by grouping and then use zero product property. So I factor an x squared out of here, and I'm left with x plus 6. And I factor a -16 out of here, and I'm left with x plus 6. So here I have x squared minus 16 when I factor out the x plus 6. And this is a difference of two squares here. So I have x plus 4 times x minus 4 times x plus 6 equals 0. So x either equals -4, +4, or -6. Now for this problem, this is about a box and it's about length, and length can only be positive. So you only can plug in numbers that's going to give you positive results, in which case -4 and -6 won't work, but 4 will. Now that's not my answer. They said find the dimensions of the box. The dimensions of the box, the length is going to be 4 plus 8. I'm going to choose that 4. 4 plus 8 is 12 feet. The width is x feet, that's 4. And the height is x minus 2, which is 2 feet. To double check all of this, 12 times 4 is 48. 48 times 2 is 96. So that is 96 cubic feet right there. These are the dimensions of your box. Pretty tricky problem. Last two problems, solving word problems, monolith mathematics. While standing on a ladder, you drop a paintbrush. The function represents the height, y, in feet of the paintbrush t seconds after it is dropped. After how many seconds does the paintbrush land on the ground? And here's your model. Okay, what I'm going to do is just show you visually. I'm going to go to Desmos here. I'm going to write y equals 25 minus 16 t squared. And it's going to give you this model, this parabola here. So this is your model that they're looking at. Okay, so here's the paintbrush. You're 25 feet above the ground. And it goes, and it's asking when does it hit. So you can kind of see an answer. Apparently it's 1.25, 0, but you won't have a graph to play with. But the reason I wanted to show you the graph is really to show you the two different answers we're going to land on and why only one's correct. It's going to be just like the last problem we just did. Only one answer is going to be correct here because, changing the window, because time is t, and t starts at 0 and it only advances forward. So we go this way and it advances forward, and this can be our only answer, the positive one. The negative one won't be the answer, even though it's just the opposite of what it was. But y is the ground. So when we're at 0 feet, that's what we're looking for. So what they're asking you to do is substitute 0 for y on the ground. That's y equals 0. So substitute 0 for y and solve for t. So I'm going to rewrite this as negative 16t squared plus 25 equals 0. I'm going to factor that negative 1 out just so we're not bothered with that. So we'll have 16t squared minus 25 equals 0. This is a difference of two squares. This is a 4t plus 5 times 4t minus 5 equals 0. So either 4t plus 5 equals 0, in which case 4t equals negative 5 after I subtract 5, and after I divide by 4, t equals negative 5/4, or 4t minus 5 equals 0. If I add 5 and divide by 4, I'll get t equals positive 5/4, which, by the way, is also 1.25 seconds. So this is your answer here. Now, the reason why the other one's not, of course, is because time's not going to go backwards. We start at 0 seconds, t seconds after it's dropped. So that means we start at t equals 0. So we find out what t is when y is 0, when the height is 0, when we're on the ground. And that's what we found. 1.25 seconds later, that's what's going to happen. And gravity works that way, by the way, guys. It increases speed as it continues to fall. These things, this negative 16t squared is not an accident. These are how gravity works when it comes to feet per second and displacement of position. Last problem. The function represents the height, y, and feet of a grasshopper, young grasshopper, jumping straight up from the ground t seconds after the start of the jump. After how many seconds is the grasshopper 1 foot off the ground? So 1 foot off the ground. Now we're going to be looking at y equals 1 here. So here you go, y equals 1. And to show you this on Desmos, of course, what this is going to look like, negative 16t squared plus 8t. So negative 16t squared plus 8t. Here's our young grasshopper. It's jumping. Now, by the way, the grasshopper's not jumping forward. This is time advancing. No, the grasshopper is jumping up and time is going. It's jumping straight up. But this is time that's moving. So if you want to know, let me make sure I wrote the problem correctly, though. Yes, I did. If you want to know here, this is when it starts its jump on the ground. This is when it lands on the ground. That's not what they ask. They do ask where it is after 1 second. The answer is going to be, how long is it going to be before it reaches 1 foot off the ground? The answer is going to be 0.25 or 1/4. Let's see if we can obtain that. I just want to show you what the graph looks like and what it is we could have looked for. They could have asked how long until it hit the ground again, plugged in 0 for y. We would have taken the latter number, 1/2 or 0.5. We're going to plug in 1 for y, though. Substitute y equals 1. So we have negative 16t squared plus 8t equals 1. Subtract the 1 over. Negative 16t squared plus 8t minus 1 equals 0. I don't like a negative quadratic. I'm going to factor that out. 16t squared minus 8t plus 1 equals 0. Okay, I see a perfect square trinomial here. I see that this is a perfect square here of 4t, quantity squared, and this is 1 quantity squared, or negative 1, because this is a negative. This is double the product of 1 and 4, negative 1 and 4. So this is going to be 4t minus 1 quantity squared. And again, if you know to do that, if you recognize it, it's good for you that you can. That's good. Negative here doesn't matter. I can divide by negative 1. It's kind of moot. Just the thing we're looking at here is this has to equal 0. 4t minus 1 has to equal 0. Add 1. Divide by 4. T equals 1/4. 1/4, not 1/2. or 0.25 seconds. That is how long after it jumps it's going to be 1 foot off the ground. There's your answer. That's it. That is 55 problems. They did it over the course of less than an hour. Yay, I did it. All right. Take care, guys. Fiend.